Assalamu alaikum everyone. Welcome to the second video of the calculus course. In the previous video we learned about differentiation, and I said in the next video in this video actually we'll be learning about integration. So before getting started with integration, let's have a quick recap on what we learned in the last class. So in the last class we learned differentiation, which is differentiation. So what is differentiation? Let's say we have a graph like this. So and let's say the equation of the graph is y is equals to x squared. So if we have a graph like this with a given equation, we can use the formulas that I provided in the previous video to find the derivative of this graph. That is, the derivative of a particular graph is the gradient of a graph at that particular point. For example, let's say this is the y-axis and this is the x-axis. For example, you have the point b, and the coordinates of b is a comma small b. The point is capital B and the coordinate is y coordinate is small b. So if you want to find the derivative of this graph, you need to use the formula of derivating square equation that I provided in the previous video. In case you forgot the formulas, you can rewatch my previous video where I provided the formula list consisting of all the formulas that you need to know according to your syllabus. So when you find the derivative of this equation at point B, what you are doing, you are actually finding the gradient of the tangent at point B. What is the gradient? Let's see. Let's say we have a sorry, tangent at B. Okay. Mm, so you're finding the gradient of this tangent. How do you find this? How do you find the gradient of the tangent? Is by finding del y by d, the change in y by change in x. So here, let's say this coordinate is x, no, not x. This coordinate is c comma 0, and it intersects the y-axis, x-axis, thus the y coordinate is 0. So how do you find the gradient of this tangent? By simply using the formula m. We represent gradient by m. M is equals to b, the y coordinate at point B, minus the y coordinate at this point is 0, divided by a, the x coordinate at point B, minus the x coordinate of this point. So minus c. So this is the gradient of the tangent of this at point B of this curve. So when you actually find the derivative of this curve at point B, you are actually doing this thing, finding the gradient of the tangent. So not always we can draw a tangent and find the gradient. Thus, we use the formulas to find the gradient at a particular point of a particular curve. That's it. That's the basic knowledge idea you need to know for differentiation. Now let's get started with integration. Okay, so let's get started with integration. Integration is the opposite of differentiation. For example, uh, we have a curve, we have a equation called y is equals to fx. If you perform differentiation to this equation, you get dy by dx. Differentiation. This arrow represents differentiation. I'm writing in short form. Okay. So if you want to take this equation back to y is equals to fx, you need to integrate this equation. Integrate this equation so that you get y is equals to fx. It's the opposite of differentiation. Integration. So let's see one example. So let's say we have a curve called y is equals to x cubed plus 3x square. So if I want to find the derivative of this curve, it's square, it's 2, not 3. This is, sorry, 3x square. Okay. So if you want to find the derivative of this curve, you will end up with the formula dy by dx is equals to 3x square plus 3 times 2, 6x. So I use the formula to derive this to differentiate this equation. You can find that formula in my previous video. And I also showed an example in my previous video derivating a similar equation like this. Okay. So I differentiated this equation to find this. Now if I want to take this equation back to y, we need to integrate this equation. We need to integrate this equation to take it back to y. So there are many formulas for integration which I will be providing right now. Uh, Integration is a bit more complex, thus I'm not telling you what integration actually is. First, let's see some problems, then I'm going to be telling you what integration actually is. So let's see what the formulas are. So these are all the formulas you need to know. In our syllabus, we are limited with these many formulas only. So let's see some examples. For example, we have a curve y is equals to x cubed plus. Let's take the previous curve. What was the previous one? It was x cubed plus no. Yes, x cubed. Let's take this one. 3x squared plus 6x. Okay. Uh, y is equals to 3x squared plus 6x. So if I integrate it according to the formula, let's see which formula applies to it. This one. This formula would be good for it. Like we have kxa plus kx plus k. So if I integrate using this formula, let's see what happens. It says put the add 1 to the power of x and divide the entire thing with the power, new power. Same thing goes here. Kx, they added the power of x here was 1. Here the power of x was 1, so they added 1 to the power which is 2 and they divided the entire thing with 2. So let's do it. Let's do it. So if I want to integrate y dx is equals to add 1 to the power 2, that is 3x plus 1, and then divide the entire thing with 2 plus 1. The same thing I do here. As the power is 1, I'm going to add 1 to it, that is 6x square. If I add 1 to 1, it gets 2, then divide the entire thing is 2 with 2. So it turns out 3, it is 2 plus 1 is 3, and there is 3. 3 gets cancelled out, then it's x cubed plus 6 by 2 is 3x squared. If you see that this equation is the same as x cubed plus x squared is the same as this equation, this one. So I integrated this one to get back to y, which proves that integration is the opposite of differentiation. I differentiated this one to get to here, and I then furthermore I integrated this equation to get back to here. So integration is the opposite of differentiation. That's the basic information. Now let's know what integration actually is.
Also, you have to memorize the formulas to be able to be an expert in integration. Thus, you can pause the video and take a screenshot, or you can just pause the video and try to memorize all these formulas in order to be an expert in integration.
So yet now we learned that when we integrate an equation, we end up with another equation, not a numerical value. For example, we have an equation y is equals to x squared. We integrate it to get sorry. We integrate it to get integration y dx equals to add 1 to the power 2 plus 1 3 by 3. We integrate it to get another equation. We don't end up with a numerical value. But integration is usually done in such a way that you end up with a numerical value. For example, integration is usually done with limits. Like integration y, we have limits a and b. What does this limit represent? Let me show you. Say, for example, you have a curve graph like this. Let's say, yeah, straight line. This is the y-axis, and this is the x-axis. Let's erase this thing. This is not required. Okay. So this is the y-axis, this is the x-axis, and the equation of the curve is y is equals to 5x. Okay. So when you integrate this curve with limits on, that is, let's say you're integrating it with integrate y with limits for a and b, let's say a and b dx. We're integrating this equation with limits a and b. It means we have two x coordinates, that is, one is a and one is b. A is before b, as a is below. As a is below b, thus a is before b. Like it's a. This x coordinate is a, and this x coordinate is b. B. So when we integrate this equation with limits a and b, we are actually finding the area of the region under the curve within these limits, like this area, the shaded area, the area I'm shading. We'll be finding that area using integration with limits on. Let's see how it's done. In the if let's say instead of a and b we have numerical values, that is, sorry, we have numerical values that ish, we have numerical values, that is, one is 2 and other is 4, let's say. So when I integrate this equation, what do we get? We get 5x, the power was 1, we add 1, that is 2 by 2, that is 5 by 2, 0.5 x squared. And as there are limits, sorry, let's say the limits are 4, 2. Okay, so as the limits are 4 and 2, how do I use the limits? Let's see. We represent this thing when we are done with the integration, like when we did find the equation of integrating y, we write the equation sorry, we write the equation 2.5 x squared, then we put our brackets beside it, and then we put the limits at the top, at the right corners, not 0, 2. Then what I do is first we substitute 4 into that equation. That is, let's put brackets 2.5 substituted 4 x squared, then bracket closed. Then we do the same thing again, that instead of 4 we substitute 2 in this equation. Brackets 2.5 substituting 2 square, and then bracket closed. Now we are just gonna subtract both these equations to get the area under the curve. Let's see what happens. 2.5 times 4 squared is 40. 40 minus 2.5 times 2 squared is 10. So 40 minus 10. Then we end up with 30. So the area under this curve within the limits of 2 and 4 is 30. 30. So what we do is when we have limits, we first take the upper limit. Upper limit means the limit that is above the other. Like here, 4 is above 2. Thus, 4 is the upper limit and 2 is the lower limit. So first we take the upper limit and substitute into the equation. Then we substitute the lower limit into the equation and we subtract both the four equations. Like 2.5, 4 square, I substituted 4 in this formula, in this equation, and then I substituted 2 in this equation and subtracted both to find the area under the curve. This is how integration is done. One thing I forgot to mention earlier is that when you integrate an equation to find another equation, that is y is equals to 3x squared plus 5, when you integrate such thing, you end up with y integrate y dx, add 1 to the power dx cubed by 3 plus 5x. As here there is no x, which means the power of x is 0. When there is no x, the power of x is 0. Thus, we add 0 to 1, that is, x becomes x to the power 1 and divided by 1, which is actually 5x. So, we end up with x cubed plus 5x. Yes, one thing I didn't mention earlier is that whenever we integrate an equation to find another equation, we always put a plus c at the end, plus c, like this. This c is a constant, which will always be a constant, it won't change. Why is that? Because, say for example, when we differentiate a formula like y is equals to 3x squared plus 7x plus 4. When we differentiate it, what do we do? Dy by dx, dy by dx. We bring the power in front. 2 times 3 becomes 6x square, 6x, and minus 1 from the power. Then 7 plus, as there is no x in 4, we put the 0. 0. So the equation becomes 6x plus 7. But if we integrate this formula, that is, integrate 6x plus 7 dx, we instead get 6x squared by 2 plus 7x, which is 3x squared plus 7x. If you see, we start, this is the part, this is not the entire formula that we started with. The entire formula is 3x squared plus 7x plus 4, but we end up with 3x squared plus 7x only. Where is the other 4? So we always put an unknown constant after every integration we do, because we never know what's the last unknown constant, that what the last constant we started with while differentiating. We never know. Like here, the constant was 4, but when we integrated, we did not know there was a 4. Thus, we will always add a c, a constant. Add a constant. Any constant, it can be c, k, a, b, c, whatever. It can be any constant, but we do have to add it, which represents the other constant that was there when we started during differentiation. These things will get more clear when I actually show some more problems in the next video. So you may ask, why did I add this constant at the end of the equation while integrating it with limits? Let's find out why I didn't add the c. Let's say we have an equation y is equals to 3x squared plus 17x cubed. Let's say we have an equation 3x squared plus 17x cubed, and we integrate it with the limits a comma b, uh, y dx. So it becomes this. First, find the equation of the limit. Equation, that is, we add power, we add 1 to the power, this becomes 3. 3 goes and divide the entire thing with the new power. Then we do the same thing again, 17x to the power 4, adding 1 to the power and divide the entire thing with 4. Then if I do add c, then what will happen? Let's see. As there are limits, we end up subtracting the same equation with substitutes by substituting the limits in it. For example, it becomes AB. First we have to substitute the upper limit, that is B. BQ plus 17 by 4, B to the power 4 plus C. Then we subtract the same equation by substitute, but instead we substitute A, that is A cubed plus 17 by 4x 4 plus C. So if you see, the C gets cancelled out. At the end of the equation, the c gets cancelled out. This minus interacts with this plus to become a minus c. Then plus c minus c, the c gets cancelled out. Thus, there is no need to input a c when you are integrating with limits. But whenever you are integrating without limits and finding simple equations like this, we are integrating 3x squared plus 5. We must add a c at the end of, must add a constant, not a c. Must add a constant at the end of the integrated equation. So these are basically everything you need to know about integration. So what integration actually is, that it is the opposite of differentiation, and it finds the area under the curve when limits and between the limits. Integration. I'm providing you with the definition of integration. It is the opposite. Yo is the opposite of differentiation, and it finds the area under the graph when limits are provided. That's it. This is the definition of integration.
In this session, we didn't look deeply into practice problems, but in our upcoming class, I will present a wide range of exercises that will include all the formulas covered in our syllabus about differentiation and integration. If you have any lingering uncertainties about calculus, I believe that the next video will be comprehensive enough to resolve them all. Till then, stay tuned with our Chesta Academy, and Assalamu alaikum. See you in the next video.